own soil. Right, so we're going to talk today about waves and rays and wavefronts. Okay, so we know what a wave looks like. So this is what a wave looks like. You know this from your from maths at this stage. Okay, it's your sine wave. Okay, it's a sinusoidal wave. That could be the function f of x equals sine of x. We don't worry about that in this, but that's what it is. Okay, right? We know that's the crest. Okay, the bottom is the trough. We're not too concerned about the name of the trough. The crest and troughs. The crest is also called peak, but we call it crest generally. Okay, and the distance from one crest to the next crest, or indeed the distance from one trough to the next trough, is called the wavelength. Okay, for when it starts repeating itself, the period. Okay, when it starts repeating itself. Right? Okay, that's the wavelength, so the distance from crest to crest. Now, the frequency, remember, is the number of crests that pass a point in 1 second. So if I'm standing here and the wave is passing, if there's 4 crests pass a point in 1 second, it's got a frequency of 4 hertz, or 4 per second. So we're happy with that, okay? And it follows from that then, that the speed of the wave, let's think about one scenario. If there's 4 crests pass in 1 second, if the wavelength is 3 meters, okay, there's going to be 4 of those 3 meters pass in 1 second, so the wave is travelling at 4 multiplied by 3, 12 meters per second. So to get the wavelength at any stage, we just multiply the frequency by, to get the speed at any stage, we multiply the frequency by the wavelength. Okay, and that's it. Okay, that's what we do. Now, what follows is very important. Okay, basically it's very important. Okay, that's your elevation from junior cert graphics. Okay, that you're looking straight in. If you look down, we know we see the crests, and we see them as lines. Okay, so if you're looking down, you look a crest there, you look a crest there, you look a crest there, and you look a crest there. So the plan view, looking down on it, we don't call them crests anymore, we call them wave fronts. Okay, so these are now called wave fronts. You can still call them crests if you like, okay, but the general term is a wave fronts, okay, and we'll be using wave fronts a lot, okay, in our sections as we go on, okay. So this is the wave model, okay, so that the elevation is there, crest, trough, wavelength, frequency, speed, okay, and then the plan view looking down on it, okay, you have the wave fronts 1, 2, 3, 4 there, okay, and again, the distance between 2 successive wave fronts, it should be obvious it's the wavelength, okay, it should be obvious that's the wavelength, okay, we'll be using wave fronts when it suits us, we'll be using this when it suits us, okay, that's the wave model. We have an even simpler model whereby, look, the wave is travelling from there to there, okay? And we have the ray model, which we'll be using in optics, okay, at the beginning, okay? We have the ray model, and instead of showing the wavefronts like that, we say, well, the wavefronts are going from there to there, so we'll make it even simpler, and we'll draw a line, okay? And that's the direction of the ray, and that's called the ray, okay? And that's what we do for lenses or mirrors. That's called the ray. Note, the ray is the direction of the wave of the waves, so it's perpendicular to the wavefront. Okay, and that's the ray. Okay, that's the basics. That's the basics of waves. Okay, and then we're going to use that when we go through to interference, and diffraction, and polarization, and lenses and mirrors and all of that. But this is the crucial first point. Make sure you're absolutely clear on the elevation, the looking in view, the plan view looking down the wavefronts, and the simplifying it up, saying if the wave is going from there to there, I'll just draw a line at right angles and I'll call that a ray model. Okay, remember we also have the photon model. We're not even worrying about the photon model at the moment, we're back to waves, rays and waves, vibration time at the moment. Okay, very good.